Let's talk about nested classes. The Java programming language allows you to define a class within another class. Such a class is called a nested class. So you can have an outer class. Within the outer class, you can define the nested classes. Nested classes have two categories, static and non-static. By using static keyword, you declared a class, a nested class, as static nested classes. Otherwise, they are called inner classes. Here, by using static keyword, we just define a static nested class. Without the static keyword, we defined an inner class. Nested classes can be declared as private, public, protected, or package private. Why we use them? It is a way of logically grouping classes that are only used in one place. So if you have a helper class that is only used inside one class, you'd better to package it inside that class. It increases encapsulation. So if class B is only used by class A, there is no reason to expose B to the rest of the world. So by declaring B as private, only A can access it. As a bonus, B have access to all the instance variable of class A. Thirdly, it can lead to more readable and maintainable code. Make your code closer to where it is used. So in order to instantiate a nested class, you need to reference the nested class through the outer class's class name. So here is the syntax. You reference the static nested class through the outer class's class name, and you use new keyword to instantiate it. In order to instantiate inner classes, you use different syntax. Here, you first need to instantiate the outer class through the outer class's instance variable. You get access to the new keyword. Then you instantiate the inner class. So here is the difference. You use the outer class's class name to reference the static nested class. Here, you use the outer class's instance to access a new keyword in order to instantiate the inner class. In both cases, you use the outer class's class name in order to reference the nested class. That is common between here and here. But at the right side, the static nested class can access new directly, but the inner classes have to access a new keyword through an instance of the outer class. Inner classes can be local classes or anonymous classes. We will cover later. Here is a shadowing effect. In the example, we have an outer class, which have an instance variable called x. The outer class have an inner class. The inner class have an instance variable with the same name x. The inner class have a method which take the parameter with the exactly same name x again. Inside the method, we try to print out x. In this case, the x is reference to the variable closest to the print line, which is a local variable passed through the method parameter. If we use this keyword, this means the closest scope, which is the instance variable of the inner class. If we are trying to reference the instance variable of the outer class, we have to reference this keyword through the outer class's class name. So by using this syntax, we are referencing the X defined in the outer class. In the main function, we first create an instance of the outer class. Then through the instance of the outer class, we get access to the new keyword in order to instantiate an instance of the inner class. Then we pass in the method parameter 23. So when X print out, the method parameter 23 is first print out at this line. This reference the inner class's instance variable, so we get what we should get. Finally, we reference the outer class's instance variable through its class name, and we get 0. This is basically what the shadow test trying to demonstrate. Serialization is strongly discouraged, and OCPJP want to cover it and want to test it, so we skip it. In the next section, we will write a program to demonstrate those points.